Terminal velocity. Terminal velocity is the function in which where resistance or friction is present while the pull of gravity is also present in a free fall motion of an object. In our project, we made two cylinders, then we filled them with two different liquids. In one liquid was oil and the other was water. Then the project was to drop a marble and then test for the terminal velocity of the object in two different liquids, which is oil and water. So our hypothesis is that that water would make the marble have a higher terminal velocity. It's because we know that as water is denser than oil, then the friction that water could create would be greater than the acceleration of friction, the time that it is required for the acceleration be equal to the gravitational constant be faster than it is for oil. Now, as we drop the water, there are three forces that acted upon it. First is the force of gravity. This is equal to mg, which is also equal to 4/3 pi r cubed multiplied the density, which is, call it p, of the ball multiplied to the gravitational constant g. Then there is the buoyancy, and that we would call Fa. This is equal to the 4/3 pi r cubed multiplied to the density of the liquid multiplied to the gravitational constant. And lastly is friction. Now friction, using the laminar flow of the fractional law of stroke, we know that frictional force is equal to 6 times pi r n r multiplied to the terminal velocity. N here is the viscosity. Solve them equations 1, 2, and 3. According to Newton's second law, we know that all forces should be equal to 0. All forces present at this problem is the buoyancy, is Fa, plus friction, minus the force of gravity. Now all of these are equal to 0. Putting equations 1, 2, and 3 to this equation, which is number 4, we get that all forces are 4/3 pi r cubed p liquid plus times g plus 6 pi n r v term minus 4/3 pi r cubed times p ball times g. Now all of this is equal to 0. Then we compute for the terminal velocity. We get that the terminal velocity is equal to 2 r squared g multiplied to the difference of the density of the ball minus the density of the liquid over 9 multiplied to the viscosity of the liquid. up. We computed that for oil and for water, the velocity or the terminal velocity of the marble for oil is at 2.62 centimeters per second, while at water, the terminal velocity is at 10.95 centimeters per second. Since we know that water has a higher density than oil, we can conclude, and the data says that as the density increases, your terminal velocity also increases. And that's all for terminal velocity.